Good morning, guys.
Good morning, sir.
How are you? Right. We're looking at the same section that we're doing on Friday. Right. I couldn't finish the part that I was doing then. I think on Friday we looked at this. We looked at percentage composition. Right. Then we looked at empirical formula. Then we're about to look at molecular formula, all right? Because of time, we couldn't do that, but I'll just go over that today, right? But before I do that, there was homework that you had, right? I wanna just go over that before I move on, right? So here, you're given exercise 29. You guys, did you do the work? Did you do this work here? Okay, Abulele is at home today. Okay, right. All right, fine. Let's look at the corrections, exercise 29. It says calculate calcium chloride is produced as the product of a chemical reaction, right? A, what is the formula of calcium chloride? What is the answer? What is the answer? Calcium chloride, SA or CA? CaCl2, CaCl2. So calcium chloride, CaCl2, CaCl2. That's calcium chloride. Calcium chloride, right? Calcium chloride. Then we move on to the next one. What is the percentage mass of each of the elements in a molecule of calcium chloride? What is the percentage mass of each of the elements in a molecule of calcium chloride? Right? What are you going to do here? Right? What you do is the following. Right? You're going to have to calculate the molar mass for calcium chloride. You have to calculate the molar mass for calcium chloride. So you're going to check on the periodic table. You've got calcium. Calcium is 40. And chlorine or chlorine, 35.5. Please, volume, because I'll have to mute all of you. Okay. Right, if you want to speak, you put your speaker. Right, the percentage by mass. Right, what are you going to do? You have to calculate the molar mass for calcium chloride. So calcium is 40, isn't it? Calcium is 40. And your chloride or chlorine, what is it? 35.5. Are we all comfortable with this? Okay, well, basically what I'm saying is this. You have to find the molar mass. So your molar mass of calcium chloride is going to be equal to 40 plus 35.5 from the periodic table. And there are 2, so you multiply this by 2. Your answer must be that one there, 110.98. Don't worry about the 98. I think it's because of rounding off. So you guys are going to get how much here? It's going to be 35.5 times 2, that gives you 71. Plus 40, that gives you 111. So here you must have 111. Do you have that? 111, that's what you get here, no? It's 111 grams per mole. Yeah. It's already 36. Okay. All right. It's fine. So yours is going to be 112. That's fine. Is it 112? Yes. Yes, it's fine. All right, then you move on to calcium percentage by mass. So you're going to say 40 divide by 112, depending what answer you have here, multiply by 100 to give you the answer there. So your answer must be around about 36. So your answers are going to be different because of your sum here, depending with what periodic table you are using. Yeah? Others, they round it off to one decimal place, others to a nearest whole number, others to 2 decimal places, and so on and so on. Right, then we move on to percentage of chlorine. Right, your chlorine, there are 2, so it's going to be 35,5 times 2. So if you used your textbook or your periodic table, if you say it's 36, you're going to have 36 times 2, which gives you 72 over 111 or 112 multiplied by 100 over 1 to give you your answer here. Right? As long as your answer it's close to this, then it's fine. Your answers are going to be slightly different here. Clear? Right, to move on to the next one. All right, so basically if we add these percentages, your answer must be 100, but it's not necessary for you to do that as long as you put those percentages. You must just know they add up to a whole. So these are fractions of the formula or the molecule of the compound that you have, percentage composition. If you add all of them, it must give you 100. Is that clear? Right, then we move on to the next question. Next question. The next question says, if the sample contains 5 grams of calcium chloride, what is the mass of calcium in the sample? So if the sample contains 5 grams of calcium chloride, what is the mass of calcium in the sample? So what are you going to do? You're going to take that percentage that you got for calcium, which is 36,15. Then you multiply it by 5. You want 36,15% of 5 grams. Clear? All right, so you're going to do that. 36,15 divided by 100 multiplied by 5 to give you 1,881 or 1,808 grams if you round off to 3 decimal places. Your answer again here is going to be different. So for people who use the, what was this? Calcium. Those who use 112, your answer is going to be slightly different here. So just work with the answer that you have here. Then if you did this, you multiply by 5, you got the answer, then your answer is correct. Clear? Right. Right. Can I move on? Right. The next one, we've got D. How many moles of calcium chloride are in the sample? How many moles of calcium chloride are in the sample? Right. So which sample are we talking about? Which sample are we talking about? We are talking about here, number of moles. Let me see here. All right, we have to do this one here. Number of moles of, the question says, how many moles of calcium chloride are in the sample? How many moles of calcium chloride are in the sample? Right, for you to get number of moles, how do you get number of moles? It's mass over molar mass. Are we together? Right, so which mass are we going to use? We're going to use that 5 there. That's the mass. Over the molar mass, what is the molar mass? The molar mass is one that for me it's going to be 111. It's going to be mass in grams over the molar mass in grams per mole for us to get the number of moles. So it's mass divided by molar mass. So basically, let me just redo this so that you understand what I'm doing here. Yeah. So basically what you're going to say number of moles is equal to mass over molar mass. which is equal to, the mass is the 5 grams that we had, over the molar mass. For me, it's 111. For you, it might be 112, depending with your periodic table. Then you get your answer there. My answer is also closer to that, maybe 0.045. That's what I'm going to get. Okay? All right. 5 divided by 111. The answer is 0.045. And this is moles, which is almost the same as that one. Another way to do it, you can just, here they're just showing you, you can also use just calcium here. You still get the same answer. So you can just say the mass that you got for calcium here over the molar mass for calcium, which is 40. Then you still get the same answer. That's another option. Are we together? Right, but the best option is this, because we wanted number of moles of calcium chloride in this sample. So you have to use everything, calcium chloride. So you have to use the 111. That will be the best option. Clear? Right. So that's your first question. That's your first question there. Right, I move on. Seriously? Okay. Right, can you move on to the next one? Right, the next one is number 2. 13 grams of zinc combines with 6.4 grams of sulfur. What is the empirical formula for zinc sulfide? What is the empirical formula of zinc sulfide? All right, so here we need the empirical formula. How do you get the empirical formula? You have to do what we did on Friday, isn't it? Right, I'm just going to do it in a simpler way. Okay, this one, they made it a bit, the example here, it's making it a bit longer, but I'll just show you what you can do. All right, you're given zinc and you're given sulfur. So what you're going to say, you're going to do a ratio. Zinc is to sulfur. Zinc is to sulfur. Those are the two elements that you are given, zinc and sulfur. Then we move on to the next step. The next step is the one where you're going to say number of moles is equal to mass over molar mass. Mass over molar mass. So I'm going to take the mass that is given there for zinc, it's 13. Right, then I take the mass that is given for sulfur, 6.4. Then I divide by the molar mass. Molar mass for zinc, if you check on the periodic table, I need to open a periodic table here. Let me just open a periodic table quickly so that we understand what we're talking about here. For just a second, I just need to, there are people who might be in the dark here. Let me just open a periodic table quickly. Any past paper would do. 10. Just check national. 2019 paper 2. 2019 paper 2. All right, just a periodic table so that we can make reference to that. Okay, I'm busy with solutions here. This is what I'm doing. Okay, right, let's check on the periodic table for zinc. All right, your zinc Zn, date is 65. So your zinc is 65, date is there. That's your zinc 65, clear? So you're gonna take the bigger number. That's your atomic number, 30, number of protons, and your 65, that is your mass number, 65. So you're gonna use 65. All right, so here I've got 65.38. It's to 2 decimal places. So I'll just use 65. Then I come to sulfur. I check again on my periodic table. It's 32. Sulfur is in group 16. So that's sulfur. Sulfur, it's a 16. All right. Then I'm going to do that. All right. Then I'm going to divide by 32. All right. Then I'm going to get the ratio here. The answer here, 13 divided by 65, 0.2. Right, then 6.4 divided by 32 again, getting 0.2. Then normally the numbers here are going to be different. So you look for the smallest one. Which one is the smallest one? In this case, they're all the same, isn't it? So you're going to divide everything by the smallest. So the smallest happens to be 0.2. So I'm going to divide everything by the smallest, which happens to be the same number, 0.2. I also divide here by 0.2. Right, my answer here becomes 1:1. So it means our formula is going to be 1 zinc, 1 sulfur. So my final formula is going to be ZnS. That's the formula for this substance here, zinc sulfide. That becomes your empirical formula. That's the formula, zinc sulfide. Clear? Right. Okay, so if I just go down, the same has happened here, but they're doing it in a like going down, not doing it like together, like side by side. So here you do your zinc, you do your moles, you do your sulfur, you get your 0.20. Then you look for the smallest one, you divide, then you come up with the ratio 1:1. Therefore, your answer becomes zinc sulfide. Clear? Please let me take note. Let me also warn you here. If your answer is 0.5, you don't have to round off to 1. You have to, let's say you divide these two numbers, you find here the answer is 0.5. You have to multiply it by 2 to make it a whole number. I repeat, after dividing, you get a 0.5 here. Don't round it off to 1. You must multiply it by 2. So let's say I get 1.5. I don't round it off to 2. I must multiply 1.5 by 2 to make it 3. Clear? I'm going to look for one question like that so that you understand what I'm talking about. Right, we move on to the next one. Let me clear here so that you see what I'm doing. The next question, it says, what mass of zinc sulfide will be produced? What mass of zinc sulfide will be produced? What mass of zinc sulfide will be produced? What do you do? How do you do this one? How do you do this one? And what mass of zinc sulfide will be produced? What mass of yes?
So I think you have to find the percentage in each of the ones.
Okay.
And then you convert the percentages to grams.
The percentage to grams, but we're starting with grams, so we're going to come back again to grams.
You can
already we have grams.
How did I get this question?
Okay. Because if we do percentage, come back to grams, it's like we just went one step back, one step forward. So we're still on the same position. Okay, yes, Joshua?
You can find the molecular mass of zinc sulfide and then use the mole ratio to calculate mass.
Calculate the mass. Okay. What about just adding 13 plus 6.4?
That was my other solution.
Huh?
That was my other solution.
Okay. You can simply add, because the ratio here is 1:1. So we can just add 13 plus 6.4, then we get our answer. Our answer becomes what? 19.4. All right? You can just do that. Okay, but let's have a look. The avenue that Joshua is talking about. So basically what you're going to do for this, you're going to say zinc plus sulfur. It will give you zinc sulfide. It will give you zinc sulfide. So what do we see? Let's balance this equation here. I've got 1 zinc here, I've got 1 zinc here, so it's balanced. This is zinc. Sulfur, I've got 1 and I've got 1. So what is the ratio here? The ratio is 1:1:1. Are you following? Right. So if I start with the zinc, I can calculate the moles for zinc here. Let me calculate the number of moles for zinc. I can say number of moles is equal to mass over molar mass. Right, which is equal to the mass. What were we given on top there? We're given 13, right? Divide by the molar mass for zinc. What is the molar mass for zinc? It's 65, isn't it? Right, so we have 65. What is our answer? We got these moles as 0.2. Am I right? Right, we found this as 0.2. So this one I'm just repeating because the number you have it already. Now I come to the ratio. We are interested in getting the mass of zinc sulfide. So what am I going to say? I'm going to compare zinc is to zinc sulfide, the ratio. The ratio is 1:1. So it means if I start with the zinc having 0.2 moles, it means zinc sulfide I'm also going to have how many moles? 0.2. Are you following? Right, so it means zinc sulfide, the moles are 0.2. Then I go on and do the formula. Number of moles is equal to mass over molar mass. The number of moles of zinc sulfide, I know they are 0.2. And the mass is the one that I'm looking for. The molar mass for zinc sulfide, I know it from the periodic table, which is what? It was 32 plus 65. What is 32 plus 65? So I'm going to write it here. It's 32 plus 65. Where am I getting this? I'm getting this from the periodic table. Then I cross multiply. My mass is going to be equal to 0.2 multiplied by 97. Multiplied by 97. Then my answer must be the same as the other one. Right, so you multiply 0.2 multiply by 97, then you get your answer 19.4. 19.4. Never mind about this one here. I'm writing with a mouse here. 19.4 grams. That's what I get, which is the same answer as simply adding those two numbers that I had. But this one, it's peculiar in a way because it's just easy 1, 1, 1. It's going to be different if it was 1, 1, 2. You're not just going to add the way we have added this one. Clear? Right. It's going to be slightly different. Right. Zinedine, are you fine?
Yes, sir.
You understand it now?
Yeah.
Yeah. So here you don't do percentage. If you do percentage, we're just going back to where we were when we started. So here you just have to use a ratio. But we're going to do this stoichiometry after this topic here, after this section. We call it stoichiometry, where you are using a balanced equation. Use a balanced equation to determine the amount of products in terms of mass, volume, concentration, and so on and so on. So you'll understand this later on. Any other question in the class? Are we all fine? Okay, let's move on to the next one. The next question. The next question says, what percentage does each of the elements in zinc sulfide contribute to its mass? All right, so this one, Zinedine, is the one that you're talking about now. Now we are doing percentage composition, so it becomes easy. So you're going to add the two, which we added, the mass to get 97. Then you say molar mass of zinc over the total molar mass. So it's going to be 65 divided by 97 times 100. So that contributes 67%. That's easy. Then the next one, sulfur, 32 divided by 97 multiplied by 100 to give you 33%. Are you fine? Right, so this is the initial one that we've done. I think that was the percentage composition is what we did when we started this topic here. Right, okay. Right, we'll move on to the next one. The next question. The next question. What does it say? It says the molar mass of zinc sulfide is found to be 97.44 grams per mole. Determine the molecular formula for zinc sulfide. Right, I'm just going to highlight here. There are two things that you need to understand. We have got empirical formula and you have got molecular formula. What is empirical formula? It's the simplest whole number ratio of elements that make up a compound. Is that understood? Right. Now, when it comes to molar mass, we need to know the ratio so that we can multiply. Let me give an example. An example would be, what can we say? The easiest example. Okay. Let me just do this here. Can I rub here? Right. For me to explain this.
Calcium sulfate.
Come again.
Calcium sulfate. No, what is the subscript is 2. Then it get what is simplified to 1.
To simplify to 1. Okay, calcium sulfate, it doesn't look like the best one. Okay, let me just do this one. Let's try a CH. Let's just say CH. All right. Then let's say there's a formula. I'm just going to come up with this. Let's say there's a formula which is C4H4. Let's say, for example, if at all there's something like this. Right. If you look at the ratios here, if this is the actual substance, and if I'm to simplify this into its simplest ratio, the ratio here I'm going to divide here by 4, divide here by 4. The simplest ratio becomes 1:1. So this is what we call empirical formula, CH, because the ratio here is 1:1. But if the actual substance is C4H4, then this becomes the molecular formula, and this becomes the empirical formula. Because for me to move from here to there, I simply multiply everything by 4. So when you're given molecular mass, we need to find that ratio so that we can multiply to get the answer. Another example would be the COO, the oxalic acid, COO, right? Actually, the actual formula is COOH. Then we multiply this by 2. That's the actual formula, right? So here, what are we going to do? The simplest ratio is, the ratio is carbon is 1:2, oxygen is 2, and hydrogen is 1. Are we together? So for every single unit here, we're going to need 1 carbon, we're going to need 2 oxygen, we're going to need 1 hydrogen. But when you find the ratio, for us to find the ratio, what are we going to say? We're going to say the ratio is equal to the molecular mass that will be given to you. Molecular mass to be molecular mass divided by the molar mass of the empirical formula. Molar mass of the empirical formula. Right? When I divide this, the ratio that I get, then I'm going to multiply this. So when I do this here, I'm going to get a 2. So I multiply everything by 2. That's how I come to this. I'm going to do that as an example so that you understand what I'm trying to say here. So here I'm just highlighting this whole number ratio, the simplest one, just 1:2:1. That's what we call the empirical formula. The actual formula here becomes, actually it becomes C2. When I multiply everything by 2, it becomes C2. And here it becomes O4. And here it becomes H2. So the ratio is going to change to 2 is to 4 is to 2. That's what it becomes. So I have to multiply everything by 2, but you'll understand this when we do an example. Right, I think that's where we ended last time. Ne? Am I right? Right, so you might have a challenge in trying to answer this. Yes, Litabo, you raise your hand.
Yes, so, sir.
Speak a bit louder next to your microphone.
Can you hear me, sir?
I can hear you, but you are faint. You are very faint. Your voice is faint. Can you increase your volume
Is
or
it
do
better
something?
now?
Come again?
Is it better now?
Yeah, it's better, yeah.
Okay, sir. Sir, what I'm saying, sir, is that you see the formula that you used, sir.
Yeah. Which one?
The ratios, to find the ratio.
Yes.
So you're saying the mole or thingy mass will be given to us.
Yeah, it will be given to you, yes.
And then the one underneath, it's,
You have to find
what is it?
It's a molar mass of the empirical formula. So if, like, for example, let me do this as an example so that you understand what I'm trying to say here. Let me do it with the zinc sulfide, then you understand. Let me just do this.
All right.
This is what you're supposed to do today. Okay, let me just clear this. Right, I'm gonna go back here to the question. So the question is saying, the molar mass of zinc sulfide is found to be 94. So here they are giving you the molar mass, all right?
Oh, yes, sir.
Determine the molecular formula. So we need the molecular formula. So what are we gonna say? We're gonna say the ratio. We're gonna say ratio is equal to molar mass, because we're given molar mass, divide by the molar mass of the empirical formula. The molar mass of the empirical formula. Right, so I'm going to divide. The molar mass is given as 97.44. So I'm going to write it as 97.44 over the molar mass of the empirical formula. What is the empirical formula that we found? We found our empirical formula to be ZNS. So I'm going to go to the periodic table and add the masses of these two. So I'm going to open here. Zinc, we said it's 65. Plus sulfur. What is sulfur? 32. Which adds up to 97. Are we together? When I divide these two, it's just simply 97.44 divided by 97. My answer is going to be 97.44 divided by 97. My answer is 1.00 something. I round it off to the nearest whole number. 1.00. So my ratio is approximately 1. My answer is 1. So what am I going to do to this 1? I'm going to go back and multiply everything by 1. Since I'm multiplying by 1, so it means the actual formula of this substance is still zinc sulfide, because I found my ratio to be 1. If it was 2, it means I was going to multiply everything here by 2. So I'm going to get something like this. I'm going to get my zinc. If it was 2, it means my formula is going to be Zn times 2. It's going to be Zn2. And my sulfur was going to be sulfur 2. That would be the formula, Zn2S2. If it was 3, it would be Zn3S3, depending on the ratio that I get here. But I'm not going to write this because this is wrong. I got my ratio to be 1. So my empirical formula is the same as my actual formula, or it's the same as my molecular formula. Is it clear now? What is his name? Litabo. Who's Litabo?
All right. So, sir, the answer we find from dividing is our ratio. Then we multiply that by everything.
Yes, by everything on your empirical formula. Yes.
All right. Thank you, sir.
Thank you. Okay. Any other question? So this is basically what we're doing today because we couldn't finish this one on Friday. So we're gonna have to, there's an activity that I have for you. And there was number 4 that I said you must do. And I said you can leave it out or try it. So we're gonna start with that one. Okay, let me finish up number 3, then we look at today's work. All right, let me move on. Number 3. Number 3. No, the answer for D would be ZNS because they asked you, the question asked you about determine the molecular formula. So you're going to determine your ratio to be 1 and you multiply it by that empirical. So your answer is still ZNS. Your final answer is not 1. Your final answer must be that 1 you multiply it by ZNS. Okay? All right, guys, our time on Zoom is going to cut us. So you're going to have to rejoin. We only have about 1 minute, 40 seconds. All right, so after you cut off, please rejoin as soon as we cut off. Right. Our lesson is supposed to end at 25 after 9, so we're still continuing here. Okay, let me proceed. Let me just delete this. Right, we move on to question number 3. A calcium mineral consists of 29.4% calcium, 23.5% sulfur, 47.1% oxygen by mass. Calculate the empirical formula of the mineral. Calculate the empirical formula of the mineral. So we need the empirical formula. So the empirical formula, where do you start? You start number ratio. We have calcium, they gave you calcium, you've got sulfur, you've got oxygen. Then for calcium, you're given 29.4. So you take that percentage to be your mass. So you're going to divide that percentage by the molar mass of sulfur, which is 40. So that's why you see here 29.4 divided by 40. Clear? Then you go to the next one, sulfur, it's 23.5. Molar mass for sulfur from the periodic table, it is 32. Then you look at oxygen, 47.1%. That's your mass. You take percentage to be your mass. So it's percentage by mass or mass by percentage. Right? You divide by the molar mass for oxygen, which is 16. Right? Then you get your answers 0.73 here. Here you get also 0.73, and here you get 2.95. Then you look which one is the smallest. You're going to divide everything by the smallest. What is the smallest here? It's